Hey everybody! In this video we're going to be learning about the arc length and sector area of a circle. This is your final video in your circle unit. So let's get started. To start with, a couple formulas to know, and these formulas are not given to you on your SOL formula sheet, so check it out. Let's think about an arc, okay? Think about a circle. Look at that first. Remember that an arc is just a portion of a circle between two endpoints, okay? So the length of an arc is a portion of the circumference. So if we wanted to know how long it was from point A to point B, we're not talking about degree measure anymore. We're talking about length. So if I got out a string and laid it on this green circle and then unwrapped it, that's a length. Maybe it's an inch long, maybe it's 4 centimeters long, maybe it's the circumference of something huge like the circumference of the sun, and we're talking about miles and miles and miles and miles, kilometers, okay? So we're talking about measurements, not degree. I'm going to jot that down because that's big. Measures length, not degree. Okay? All right, so here goes our formula. The arc length is going to be equal to the portion, and the portion we're talking about comes from the arc's degree out of the total 360 degrees of the circle, times the circumference, because we're saying that the length of the arc is a portion of the full circumference. Okay, well, if you don't want to have to kind of first find the circumference and then multiply it, you can make one big formula that says the arc length is equal to the arc's degree out of 360 times, now think back, what's your circumference formula? I'm thinking back to my doodle notes here. The circumference formula is 2 pi r, and that is on your SOL formula sheet. So this is the formula I'll be using for arc length. Let's do a couple of examples. It says, find the arc length, not the degree measure. Write the answer as an exact simplified value. That's going to be new for us. Also, write the answer rounded to the nearest hundredth. Okay, so let's check out example 10 here. From E to B is 15 centimeters. Well, that's handy. That looks like our radius from E to B. We also have this arc measure here, angle and arc measure of 68 degrees, but that goes with arc BC. We're looking for arc C to D. I'm going to put an X out here on arc CD. So take a look at our formula. We have arc degree out of 360 degrees times the circumference, 2 pi r. Well, right now, all I know is what the radius is. The radius is 15, so 2 times pi times 15. What I don't know is what our arc's degree is. The 68 doesn't match up to our arc. But we've done lots of practice now in this unit, and we know how we can find that missing arc. Let's take a look at this circle. Our missing arc and the 68 degrees totals half of the circle. Half of a circle adds up to 180. So 180, take away our 68 degrees, leaves me with 112 degrees for our arc. Now, that is not our answer. We are not finding the measure of the arc. We're finding the length of the arc. They're two separate things. The measure of the arc is 112 degrees. The length is something we still have to work on. Now, the first set of directions here says to write our answer as an exact simplified value. That exact part means you need to leave pi in the problem. Leave pi in there. Otherwise, you'd be rounding because pi is an endless irrational number. So I'm going to pull out my calculator and I'm going to type in everything in this formula except for pi. Let me show you. Okay, what I want you to do is grab your calculator and I'm going to cover up pi. I want you to type everything else in your calculator exactly as we have written it. Fraction 112 over 360 times 2 times 15. You should get 28 over 3. If you don't get 28 over 3, come find me so I can show you how to type this in your calculator. Now, 28 over 3 is not our answer. 28 over 3 pi is our answer. This is our exact length, and that would be centimeters. This one was measured in centimeters because the radius was measured in centimeters. So this is our exact, because pi is still in it, simplified because our calculator has simplified all the math. Okay. We also want to practice getting the rounded answer. So now I want you to type in 28 over 3 times pi and see what the rounded version is. You should get that that's about equal to 29.32. And remember, that's in centimeters. So both of these are correct answers. The answer that still includes pi is called the exact value. The answer that we have used the pi button is the rounded value. Both are present on your SOL test. Both need to be understood. Okay, let's try example 11. If NR is 8 feet, there's NR, that's our radius. Find the length from N to M to P. Look what we're looking for here. N to M to P. All right, in our formula, we need to know the arc degree and we need to know the radius. We've been given the radius. The radius is 8. We have not been given our arc degree for this full blue arc that I've highlighted. We have been given 162 degrees from M to Q. So we have a little bit more work to do. Okay. Let me reason through this with you. If M to Q is 162 degrees, then so is N to P. That's vertical angles. I know that the circle all the way around adds up to 360 degrees. So 360 degrees, take off this non-highlighted piece of 162, is going to leave me the highlighted part. That's 198 degrees. So from N all the way around to P is 198 degrees. That helps me fill in my entire formula. The arc degree is 198 out of 360 times 2 times pi times the radius of 8. All right, remember, when you are trying to find the exact simplified value, you want to type in everything except for pi. So you'll be typing into your calculator 198 over 360 times 2 times 8. You should get 44 over 5. Now, we didn't hit the pi button, so pi is still there, and that is our exact simplified value. This is a measure in feet. To get the rounded value, all I have to do is take my fraction and multiply by pi, which rounds to 27.46, I believe. Oh, nope, 27.65. And that's still in feet. That is the length of the blue arc when the radius is 8. Okay, so arc length, you are trying to find how long the designated arc is. The last piece here is sector area. Now you may have already done a little bit of this lesson back in G.13. If so, see if it's still familiar to you. Let's take a look. Let's refresh what a sector is. Within a circle, a little wedge of the circle is called a sector. So this shaded area, this is a sector. The sector area is the area of the sector, which is a portion of the total area. So these two formulas, sector area and arc length, are really the same. The length of an arc is a portion of the circumference. The area of a sector is a portion of the total area. Okay, so our formulas are going to be similar. Our portion comes from the arc degree out of 360. This is a portion of the total area. Well, if you think back to your area formula, or if you look it up in your notes or on your formula sheet, area formula is pi times r squared, pi times radius squared. So I'm going to be using the formula arc degree out of 360 times pi r squared. Let's see it in action. Directions say, find the area of each sector, write the answer as an exact simplified value. Also, write the answer rounded to the nearest hundredth. So again, we have to be familiar with two ways to express our answer. So let's see what we get. Write down my formula here. Arc degree out of 360, there's the portion, times the total area, pi r squared. Well, in this picture, I've been given 7 as the radius. So I'm putting 7 in the r position. And nicely enough, they've given me the angle, the central angle is 154, which means the arc degree is also 154. So I have arc degree of 154 out of 360 degrees times pi times the radius of 7 squared. For my exact answer, I'm going to use my calculator and I'm going to type everything in just as I've written, except I'm going to exclude pi. So I'm going to type in 154 over 360 times 7 squared. What a nasty answer. 3,773 out of 180. And don't forget, we have not used pi yet. Now, when we're talking about area, we're talking about squared units. So this is in kilometers squared. This version of the answer doesn't look very helpful. Let's also check out what our area would be when rounded. I'm going to take this fraction and multiply it by pi. I get 65.85 and that's still in square kilometers. You guys, both of these answers are valid. The first that still has pi in it is our exact value. The second, written as a decimal, is our rounded value. You need to be able to express your answer both ways, depending on the style of the question. Okay, one more example so you see it twice. Let's take a look. I'm writing down my formula so I know what to look for. Arc degree out of 360 times area, which is pi r squared. All right, it looks pretty clear what our radius is. Our radius is 15 feet. What is unclear this time is what our arc is. That's what we don't know. What we've been given is a mega angle and major arc of 332 degrees. 332. Well, remember, all the way around a circle is 360 degrees. And if I'm using 332 degrees as the major arc, I can subtract to figure out what the minor arc would be. 360, take away 332, leaves me with 28 degrees for my minor arc, which is the arc that goes with this sector. So my arc degree is 28 out of 360 times pi times the radius of 15 squared. When I write up my exact answer, I'm going to use the calculator, but I am going to ignore pi. I'm going to type in everything else. So I will type in 28 out of 360 times 15 squared. I'm getting 35 over 2. Bring down the pi. My exact answer is 35 over 2 pi feet squared. To get the rounded answer, I simply multiply 35 over 2 times pi. That gives me 54.98 feet squared. All right, congratulations. You have finished your unit notes for all of circles. This is a tough unit. There are so many formulas floating around. Please make sure you grab a formula sheet from me. It'd probably be a great idea to make some flashcards with the main formulas and just practice, guys. The IXLs for these are really helpful. Happy studying!